Okay, today we're going to work on solving rational equations. I'll do a few problems for you. So let's go ahead and jump in. So just like any other type of addition or subtraction, we need to find when we have multiple terms on one side, if you look at this side, we have multiple terms. We need to be thinking about finding a common denominator so we can combine these terms. And looks like we already have a common denominator here. So when we have a common denominator, we can simply add straight across. So I'll do 3 over m squared. And remember, when we have a common denominator, we just keep the one denominator and we add straight across. So what is m minus 4 plus 2? We can say 3 over m squared equals m minus 2 over 3m squared. So now there's a number of ways to solve this. We could use solve by proportion with cross multiplication. In this case, I think a clever way to solve this would be if the denominators were the same here, we would know that the numerators also had to be the same. So a little clever way to solve this, if we multiply this side, both the top and the bottom by 3, our new equation, 3 times 3 is 9, over 3m squared equals m minus 2 over 3m squared, right? And if we know the denominators are equal, then that implies that the numerators also have to be equal. If this thing's stating that it's equal, then when denominators are equal, it implies that the tops have to also be equal. So we can simply say 9 has to equal m minus 2. So we can add 2 to both sides and get m equals 11 here. So let's look at another one here. In this case, we do have two terms on the right side, but they are not common denominators. We have this 2x squared and this 6x squared. So before we begin our process, let's go ahead and make a common denominator. I'm just going to go ahead and bring our 1 over 3x squared down. And I know that 2 can be multiplied to turn into a 6. So let's just go ahead and multiply the top and bottom of this by 3. So that way we can have our 6x squared on the bottom here. So that means on the top, though, we have to be careful to keep this in parentheses because we can't cherry pick which one of these terms we want to multiply by 3. We have to multiply the whole top by 3, which means we're going to have to distribute this. So that would mean our new numerator is 3x plus 9. So we've done a good job here of finding ourselves a common denominator, and I'm going to go ahead and rewrite our 1 over 3x squared equals, now we know our common denominator is 6x squared, so we can just do this operation straight across. Essentially, we have 3x plus 9 minus 1. So moving it up here, we can say 1 over 3x squared equals 3x plus 8 over 6x squared. So we are getting close, but similar to our last problem, wouldn't it be nice if this denominator and this denominator were the same? So we knew that if the denominators are the same, that implies that the numerators are going to be the same if these things are equal. So we'll have to multiply both the top and the bottom here by 2. So our new numerator on the left side is 2. Our new denominator on the left side is 6x squared, and that will equal 3x plus 8 over 6x squared. And now, because these two things are stated to be equal, if our denominators are equal, that implies that our numerators are equal. So we can pretty much just simply ignore these and say 2 has to equal 3x plus 8. Now we're getting down to some simpler algebra. We can cross the 8's out by subtracting on both sides, and we get -6 equals 3x, dividing both sides by 3, allowing us to cross out our 3's, and we get 2, or -2 equals x.